In this video, I will explain you Hellwach and Lenards experiment. This is the experimental setup. We have a glass tube, and to the either side of the glass tube or either end of the glass tube, I have attached a metallic plate, and these metallic plates are connected to a power source. So there are a switch made in this way. I will explain this later. What is this switch represent? So basically they are connected to a power source through an ammeter and a voltmeter. So this voltmeter measures the potential difference in between two metallic plates, and the ammeter basically gives the value of photoelectric current. And why we are calling it as photoelectric current? Because the reason here is the cause that produce the current here is photoelectrons. See, when the light having sufficient energy falls on a metallic surface, this will emit electron. And what is this process called as? Photoelectric emission. So as this metallic plate emit electron, this is called as emitter plate. Now what will happen to this electron? If I am connecting this terminal with the positive side of the battery, this will also get a positive potential. And now this electron will be moving towards the positive potential, because there will be a force on this electron to come inward, to come in this direction along or towards the positively charged plate. Now this electron from the emitter will move towards the other plate. Now this electron will be collected at this plate. So this is termed as collector plate. This is very important. Okay, so this is the experimental setup. Now when this plate is incident by a radiation having sufficient energy, what will happen? The electrons will be emitted out, and if I am connecting this plate with the positive terminal and this plate with the negative terminal, these electrons will move towards the positive charged plate, and that will form a closed circuit here. So we can measure a photoelectric current here. Now there is two variables here. One is intensity and another one is frequency of the source. Now source is nothing but I can take it as a bulb. Now this bulb can be made with different intensity and can also be made with different frequency. Now what is frequency? We can see different colors of light because it is possessing different frequency. So with GR, violet, indigo, blue, green, yellow, orange, red. So these are possessing different colors because their frequencies are different. Now in red color also you can see dim red color and medium bright red color and extra bright red color. So the reason is, for example, 100 watt bulb, 500 watt bulb and 1000 watt bulb. So all these bulbs are giving red color light, but this with less intense, this with more intense. So intensity is nothing but take an area and see how many light rays are incident on that area. If more light rays are coming, then I could say that this is intense light. So in an area, if more amount of light comes, then that light source is an intense light source. But if lesser number of light rays are coming or passing through an area, that is a light source with lesser intensity. So simply I can measure it with the rated power. The light which are having lower power rated has got lower intensity, and higher power rated has got higher intensity. So 100 watt bulb will be having higher intensity as compared to 40 watt bulb. So changing the watt rating of the bulb, we can change the intensity, and changing the color, we can change the frequency. Now one thing is very sure, if I am using, this is logically correct, if I am using a lower intense power source here, that will be giving very less number of electrons out. So that will be represented by a lesser photoelectric current. So intensity is less, photoelectric current is less. Now I have increased the rating to 500 watt. Now higher intensity will give out higher photoelectric. So if 5 are coming now it will be 50 coming out. Okay, so more current. Now again I am increasing the intensity. So the example here is green color light of 100 watt, 500 watt, 1000 watt and 10,000 watt. Intensities are increasing. So higher the intensity, more number of photoelectrons will be given out, and that will give rise to a higher amount of photoelectric current. So I can say that they are directly proportional. Higher the intensity, higher will be the electric current. It will be a straight line. Now in the coming video, we will see the variation of or dependence of frequency on photoelectric current and some other parameters as well. Okay, thank you.